Hi, welcome back to another episode of our AKS cost management series. In this video, we'll explore how to autoscale your infrastructure and use node auto-provisioning tools to cost optimize your AKS cluster. Autoscaling allows you to scale up to meet demand and scale down to save on costs. In the last video, we covered how horizontal pod autoscaler, vertical pod autoscaler, and Kubernetes event-driven autoscaling can help you scale your pods to improve node unpacking. To scale the infrastructure or the nodes of your cluster, AKS also has various options: cluster autoscaler or node auto-provisioning. Within AKS, you have to pick between cluster autoscaler or node auto-provisioning. The two features cannot be enabled on the same cluster at the same time. Cluster autoscaler automatically increases or decreases the number of nodes in your cluster based on pending pod resource requests. If there's not enough allocatable resources for the pods to get scheduled on an existing node, then Cluster Autoscaler will create a new node of the same type in the node pool to meet the application demands and get the pod scheduled. It also regularly checks nodes for a lack of running pods and scales down the number of nodes when demand is low. When enabling Cluster Autoscaler, you specify the minimum and maximum number of nodes to scale to. Cluster Autoscaler will also enforce a minimum node count in cases where the actual node count drops below the specified minimum due to external factors such as during a spot node eviction. We'll talk more about spot in just a moment. Cluster Autoscaler can and should be used alongside horizontal pod autoscaler or vertical pod autoscaler. So when you grow to more or larger pods, your infrastructure can grow with it. On the flip side, when resources are no longer needed, Cluster Autoscaler will drain the node and reschedule the pod to an existing node in the cluster, so you aren't paying for additional infrastructure that is hardly getting used. Keep in mind you will want to use a pod disruption budget to ensure that you don't negatively affect your application when Cluster Autoscaler performs the drain operation to remove the node from your cluster. Cluster Autoscaler can be enabled cluster-wide or to specific node pools. And you can further fine-tune the cluster autoscaler profile to control how aggressively it scales in and out. For example, if you want more rapid scale-in, so empty nodes are up for as short of a time as possible before getting drained, here are a few settings that you can tweak. Reduce scale-down delay after add, and scale-down unready time. Increase scale-down utilization threshold, and max empty bulk delete. Also, increase OK total and ready count and max total and ready %. For more information on the settings, defaults, and different profile configurations, check out our AKS docs on how to use a cluster autoscaler on AKS. So Cluster Autoscaler is responsible for scaling the nodes count up and down based on pending pod resource requests. What about node auto provision, or NAP? NAP similarly automatically provisions new nodes based on pending pod requests, but rather than spinning up a new node of the same type, NAP will provision the most cost-effective SKU for your workload. It abstracts away the complexities of picking the right VM configuration for your workloads that may require different amounts of CPU, memory, and capabilities to run. When you enable NAP, it will use a list of VM SKUs as a starting point to decide which is best suited for the workloads that are in a pending state. You can control what SKUs you want in the initial pool by specifying this in a node pool definition. If you have specific VM SKUs that are reserved instances, you can use NAP to only pick those SKUs as the starting pool. There are many other SKU selectors that you can also specify in your node pool definition, such as capacity type, SKU family, on-demand or spot, CPU architecture, and many others. Using spot nodes with NAP can help you achieve massive cost savings. Spot prices are up to an 80% discount relative to on-demand compute and can be used for workloads that can tolerate interruptions, evictions, or early terminations like batch processing jobs and dev test environments. You can have multiple node pool definitions in a cluster and have NAP configure separate pools for spot and on-demand capacity. And if you want your workload to have a scheduling preference for spot nodes, apply a higher weight to the spot node pool. You could do the same for an ARM64-based node pool too. ARM64 VMs are engineered to efficiently run dynamic, scalable workloads that deliver up to 50% better price to performance when compared to x86 VMs for scale-out workloads. NAP will also consolidate pods across nodes with low utilization, meaning better bin packing and less idle resources. The new node may even be a different SKU that is more cost-effective than the original node. So to summarize, autoscaling infrastructure to dynamically manage nodes and optimize resource usage will ensure that your workloads are running smoothly and efficiently. Using one or a combination of infrastructure autoscalers and workload autoscalers will help you achieve significant cost savings, ultimately reducing operational costs and removing the need for manual interventions.